question number 4 is definitely one of the harder problems, if not the hardest exam problem for exam 3. And it says a cylinder of radius b, so it's calling the radius equal to b, so has a moment of inertia equal to 1/2 mv squared. So I equals 1/2 mv squared. Remember before I said I equals 1/2 mr squared? Well, he just decided to call the radius b. So we'll go ahead and use his definition. The cylinder is rolled along a flat horizontal surface. So if we drew a picture, you'd basically just be rolling it up a slope. We don't really have to pay any attention to it. I just wanted to show you what it would look like. At a speed v, so when it hits the ramp, it will have to travel a height of 50 centimeters. So it's going up a height of 50 centimeters at a speed v. What is the initial speed of the cylinder? So we're looking for v initial. This question is very difficult because it only gives us one number and a formula. So, first thing you have to recall here is if you want to get something out of a height, you're most likely going to use conservation of energy, which has to do with potential energy and kinetic energy. Well, kinetic energy for inertia is a little bit different. Rotational kinetic energy, so we will call it rotational kinetic energy is equal to 1/2 IW squared. So, we know that W is a velocity, rotational velocity, omega, but we have no rotational velocity. But if you guys remember from back last test, V equals RW. So linear velocity is equal to the radius times the angular velocity. So if we go ahead and rearrange this, we could say W equals V over R. So linear velocity and radius. So now we have something that we can kind of relate back. Linear velocity and linear velocity. Remember here that Dr. Sullivan said radius is equal to b. So just not to confuse you, I'm going to go ahead and call this radius b. Even though when I like to do these, I don't like to use the radius as b. So the first thing that we want to do is if we know that rotational kinetic energy is equal to 1/2 IW squared, let's go ahead and solve for what rotational kinetic energy equals. 1/2 I is equal to 1/2 mb squared, so 1/2 mb squared, and W is equal to V over b squared, and that is equal to, the b's end up crossing out, and the 1/2s end up multiplying, so we end up getting 1/4 mv squared for our rotational kinetic energy. Once we have the 1/4 mv squared, we still have to add it back to our original 1/2 mv squared. So if we go ahead and do that, we do 1/4 plus 1/2 gives us 3/4 mv squared as our kinetic energy. So this is why this problem is complicated, because we had to find out the rotational energy and add it back to the kinetic energy. So just like before, we had potential energy initial plus kinetic energy initial equals potential energy final plus kinetic energy final. Well, if initially the ball is rolling, there's zero potential energy. So we have the kinetic energy. And then we have the potential energy. The cylinder is now at the top when we're final. So we have potential energy here, but no kinetic energy. So we can go ahead and say kinetic energy, which is equal to 3/4 mv squared is equal to potential energy, which is mgh. You have to recall that potential energy is equal to mgh, and kinetic energy we derived is now 3/4 mv squared. So be very careful, because he could easily change not this 1/2, but the 1/2 from the inertia. So if it's a different object, it might be 2/5 mv squared. So now that we have all the necessary components, it's the same object, our masses cancel out. We can go ahead and multiply by 4/3 to the other side. So v squared equals 4/3 times gh. To solve for v, we're going to go ahead and take the square root of 4/3 times gravity times the height. So velocity of the object is going to equal to the square root of 4/3 times 9.8 meters per second squared times 0.5 meters, because that's 50 centimeters. And our velocity here is equal to 2.6 meters per second, which is answer choice A. So this is definitely by far, I think, the most complicated question on the exam, because you have to remember rotational kinetic energy was equal to 1/2 IW squared. Then you had to substitute whatever the inertia was in for I. Then you had to recall what linear velocity equals in relationship to rotational velocity. And then we can go ahead and solve to get our answer of 2.6 meters per second.